any issue with you. Done. Let's start the chapter now. So basically, we have the A2 unit over here, and that is forces and momentum.
Yes.
Okay. Now, what is a force? When I define the force, basically this is a cause behind any motion. Correct?
Yes, ma'am.
Yeah. So when any motion is created, we say that the cause behind this must be the force, which is a applied force. Okay. And when you give the IB definition, so you will write it in IB as product of mass and acceleration. Okay. Even you can write it as for 1 Newton as when 1 kg of mass is accelerated for 1 meter per second square. Done?
Yes, ma'am.
Okay. Any doubts?
No, ma'am.
Great. So this is force. This is the normal definition that you will try to understand, that whenever there is a cause, because in the first chapter I had taught you motion, right? The types
Yes.
of motion, the types of equation involved in it, Newton's era thoroughly we have done. Then now the next chapter is force. So what is force? The cause behind that motion. Okay, the product of mass and acceleration. So basically,
Sorry to interrupt you, Miss Aarti. Akshita, can you hear me?
Yes, ma'am.
Yeah, Bache, is it possible for you to join your class every day at 8:30? Like, without changing, we are not supposed to change your timing then every day.
8:30 to 10 I have another class, ma'am. Like,
So, is it can you share the possibilities, like on Monday, whatever the slots you have, for Tuesday, whatever the slots you have, so that we can fix it up?
yes, ma'am.
Right.
What about 5 to 6? But also, 5 to 6 won't be possible because Saturday I have a class at 6 to 7. So there might be a. I'm going
Except Saturday, are you okay with 5 to 6?
Yes, ma'am.
And what about Miss Aarti? Are you okay?
I'm not okay on Wednesday and Thursday. Other than that, it will be fine.
And Wednesday and Thursday, what slot you have?
Wednesday I have classes 8:30, 7:30. I kind of like I rescheduled the classes, ma'am. For 7:30 I had math class, so I changed it.
Okay, Wednesday you can join 6:30 na, as you have joined today, right?
Yes, ma'am. Wednesday I can join.
Okay, Wednesday we can keep it as 6:30. And what about Thursday, Akshita?
Thursday at 6 to 7, ma'am, I have a class. So half an hour, like
4:30 to 5:30, can you join?
4:30 to 5:30. Thursday, ma'am.
Yeah.
I will let you know, ma'am. Or I can like change the classes again if we need to keep it at 6 o'clock, then I can again change my math class at 7:30 if possible.
If it is possible, you can have the same schedule as you were having prior, and you can make every day at 8:30. And
No,
you can
no.
align your maths classes at 7:30.
No, 8:30 won't be possible, ma'am, because the teacher kind of works and comes back, and so the only time possible for her is after 8:30.
I think we can do one thing, na? We can do one thing.
Yes, ma'am.
As Miss Aarti said, she's okay 5 to 6 every day except Wednesday and Thursday, right, ma'am?
Yes,
Yeah.
ma'am.
So you can take every day 5 to 6, correct?
Yes, ma'am.
And what you can do, you can join at 6:30 Wednesday and I think
Thursday alone there is an issue, and Saturday I won't be able to join at 5 to 6. I will be traveling.
okay, you can share what you can do, Akshita. You can share your slots of Thursday and Saturday with me, and then I will match up with Miss Aarti. Okay.
Yes, ma'am.
Yeah, Akshita, at
Okay.
least provide two slots so that I can align my timetable also with yours, right?
Whatever the number of available slots you have, you can share it with me. Okay.
Yes, ma'am.
Chalo. Okay, bache. You can don't waste the time. You can just share your available slots of Thursday and Saturday with me, and then I will align with. Okay.
Okay.
And then I will share the timings of each and every day with you. Okay.
Yes, ma'am.
Okay, bache.
Fine. Now, Akshita, what I was telling is that force is nothing but the cause behind any motion. But when you write in IB board, you have to align it with the IB definitions, which says that the product of mass and acceleration is known as force. Done. Now,
Yes.
force is a vector quantity. Okay. It is a, wait, what happened this? Okay. So basically, what I was telling is it is a vector quantity. Done.
Yes, ma'am.
Okay. Next, it is a vector quantity. What are the types of forces that exist in nature? Okay, let's check out that. So basically, we have two types of forces when we study about their contact surfaces. So non-contact and their contact. Okay, now let's talk about non-contact and contact. So in non-contact forces, we have gravitational force, we have electrostatic force, we have magnetic force. All these three forces are there in your syllabus. We will do it one by one. Done. After that, let's give a study about contact forces. So what are contact forces? So basically we have the tension force. Done. Then we have the normal force. Done. Then we have the spring force. Then we have the centripetal force. Then we have the frictional force. Okay. Let's have a look at them one by one. In this chapter, we have to discuss all these forces. Understood, Akshita?
Yes, ma'am.
Done. So let's have a look over this one by one. And what happened?
Ma'am, are you did you stop sharing the screen?
No, I haven't stopped sharing the screen, but yeah, it got some mishap in between. So that is what I am even checking. Okay.
Yes.
Yeah. Check. Is it now visible?
Yeah, yes, ma'am.
Yeah, it's visible, no? Fine.
Yes.
So let's do the next now. And that is, yeah. So basically, let's discuss all the forces one by one. And the very first force is your gravitational force. Okay. Gravitational force, basically, we will going to discuss as weight in this chapter. Done. So gravitational force is what? If suppose this is the surface of Earth, then every object, every mass tends to be attracted towards its center. Every mass tends to be attracted towards its center. Now at this line, you will observe that at surface, it always behave as a normal line. Behave as a normal line. Done, because it is 90 degree. So obviously it will be normal line. Done. Next thing.
Yes.
You have to keep in mind that 1 kg is 10 Newton or 9.8 Newton. Clear?
Yes,
Okay.
ma'am.
The formula with which we define the gravitational force is capital G m1 m2 over r square. Done?
Yes, ma'am.
What does this force formula define us? That if suppose I have one mass over here, let's say m1, as one mass over here, let's say m2, they are aligned with their centers. Let's say they are aligned with their centers. Done? Then what
Yes,
happens is, from their centers, first thing, it is an attractive force in nature, Akshita. It never repel. Done? Second thing, it is a central force, Akshita. It never get applied from any other place of the mass. If any mass is there, you will always apply the force of attraction from its center. Okay? And third thing, here we basically talk about the celestial objects which are kept at a very far distances. Akshita, are you getting?
Yes, ma'am.
Wait. Okay. Am I visible to you?
Yeah. Yes, ma'am.
Yeah, that's nice. So now check. What I'm saying is gravitational force is applicable for the celestial objects. What are celestial objects? Other than Earth, when we have any other planet or any other celestial object which are revolving around in the universe, then they will be treated as masses in
Yes,
this
ma'am.
particular law. Okay. So this is Newton's gravitational law. It defines that if one mass is in the verge of second mass in the area near around, okay, then what happens is m1 applies a force over m2 and m2 applies a force over m1. How does it apply? It applies the force with the formula G m1 m2 over r square.
Yes, ma'am.
Done? G m1 m2 over r square, and hence it can also be defined as the force is directly proportional to the product of mass m1 and m2, and it is inversely proportional to the square of the distance between them. So if you increase the distance, obviously the force will going to be decreased. Understood?
Yes, ma'am.
Any doubts?
No, ma'am.
Okay. So now the force with which you are attracted towards the center of Earth is known as your weight. This weight is basically defined as mg because it is a force due to gravity. Done? So weight is nothing but a force. Formula is mg. Mass into acceleration due to gravity. Formula is F equals to mg. Done?
Yes, ma'am.
Any doubts?
No, ma'am.
Sure?
Yes, ma'am.
Okay. Now let's have a look at the other force, and that is your normal force. Okay. So what is normal force basically? Normal force will be defined as the force which is acting as a reaction force to the gravitational force. Are you getting what I'm trying to convey? I'm saying a force which is acting as an opposite force, as an opposing force to the force of gravity. Okay, like here if I have a mass, let's say m, and here I have w. So w will be equals to mg.
Yes,
And
ma'am.
here the counteracting force will be your normal force. The speciality of normal force is it is always acting at 90 degree to the surface of contact.
Yes, ma'am.
Done? So you
Yes.
have to always draw it at 90 degree. Done? Now it is caused due to the contact of the two surfaces where weight has been applied.
Yes, ma'am.
Making sense?
Yes, ma'am.
Done. Now the next thing that we have in picture is your tension force. Okay. Now what is tension force is basically, if suppose I have any string, if I have any rod, if I have any chain, okay, then this particular force will be applied via this. Let's have a look over this. Okay. Suppose I have here a fixed terminal with which I am tying a string. So this is my mass m, suppose. Always the tension force is created from where you are applying. Suppose I am sitting on this mass and I have to apply tension force in my rope. Okay. I had told you that it is always applied in the string. It is always applied in the rods. It is always applied in the springs. Okay, like that. Wherever the thing is hanging in nature, wherever the elasticity is there. Understood? So
Yes, ma'am.
you will always apply tension force from the thing where you are sitting in the opposite direction. Okay, just like you have to sit over the mass and you have to open the umbrella. Where does the umbrella opens? In the opposite direction. One more example. Let's say this is the fixed point. From here I am tying my object mass M. Okay, and here I am tying this object to a horizontal surface. Okay, so if I sit over here, then I will keep my tension force in this direction for mass M.
Yes, ma'am.
And if I am sitting here, then I will apply the tension force over this direction for mass M. Okay.
Yes.
Now let's suppose for pulley, I am tying a thread in this direction for mass M, and it has been told that find the tension on the string due to pulley. Then I will sit on the pulley and I will apply my tension force in the opposite direction.
Yes,
Hmm?
yes.
Tension force does not change until and unless string remains the same. Example, this is my pulley. Here I have the string. The same string is going this side. Here I am tying a mass, let's say M. Here I am tying a mass, let's say M1. But the string is same. So both the sides, your tension will remain the same.
Yes.
But if the string changes, let's say this string is different from this string, then the tension will be different.
Yes.
Understood?
Yes.
Any doubts?
No, ma'am.
Great. So after this, we have your free body diagram. Now, what is free body diagram?
Has normal force, G, and tension all together.
So basically, free body diagram is defined as where we take the body as point mass. Then we show all the number of forces acting on the body with vector diagram. Correct? Vector arrows we show. And also for the force, we should be having a reference frame of the observer. Okay. Like there are some conditions where the frame of reference. Do you know what is frame of reference?
The XYZ.
Yeah. The coordinate system from where you are observing a given event.
Yes.
Okay. So the coordinate system XYZ from where you are observing a given event. When you are in the moving frame, then to look at the object becomes different. But when you are at steady state and to look at the given object becomes different. Okay. Yeah. So when you are in moving frame, one more force comes in action, and that is your opposing force. Equal and opposite force also comes in the action. Okay. Like
Yes.
I can give you an example. Suppose here I have the swing and here I am sitting. So I am also moving with the swing. So inward I will apply the centripetal force, and outward I will have a centrifugal force which will be counteracting this force. That means they both will be equal
Cancel.
and opposite. Right?
Yes, ma'am.
So this is how it works. Done? Any doubts till now?
No, ma'am.
Okay. So suppose I have a sledge like this, and here I am keeping the mass. How many number of forces are acting over it? So you will show it something like this. This is my dot M. So this is my normal force.
Yes,
This is my mg force.
Yes, ma'am.
Correct?
Yes,
This is my sliding force. And this will be my frictional force.
Yes, ma'am.
Any doubts?
No, ma'am.
The distance of the arrow shows that which force is bigger in nature in the given criteria. So here if mg is small and frictional force is high, that means the object is at rest because frictional force is very, very high in comparison to sliding force and the weight force. Understood?
Yes,
So
ma'am.
when you are drawing the diagram in exam also, you have to make sure in boards that what will be the length of the force need to be kept so that you can actually check with the clarity of that. Okay? You can justify that. Understood?
Yes, ma'am.
Okay. Now after that, we apply all these forces with the two ways. The very first way is Newton's first law of motion. And the second way is second law of motion. Let's have it one by one and check what do they give us. Okay. So in Newton's first law, it directly tell me that until and unless you are not applying any external force, okay, the object will stay at rest or in uniform motion. Right? So when the object is staying in uniform motion, it means there is no external force. Right? So it is
Yes.
telling me an idea when the force is 0. That means F equals to MA. My MA is also constant or either it is 0. Correct?
Yes, ma'am.
So that means there is no momentum or it is a constant momentum. Constant momentum means constant velocity. There is no acceleration happening, right? So basically, this tells me thoroughly about what happens when the force is 0. So when the force is equal to 0, what happens here is, wait, I had written it by mistake like this. So it will be F equals to 0. Okay. So what happens here is, basically, if the force is becoming 0, this simply tell me that when my force is completely 0, no object comes in action. Okay? No object comes in action and they stay in the equilibrium state. What is equilibrium state? The state where all the forces acting on the object is
Reach its
0.
maximum.
Sorry?
No, the equilibrium in
Resultant force and resultant moment of
Is
force
zero.
is 0.
Okay.
Okay. Suppose
Yes.
here I have an object like this mass m, then this mg will be equal to the normal force. This
Yes.
frictional force will be equal to the sliding force. Okay.
Yes.
So basically what is happening is when all the four forces are equal to each other,
We are in
it will
equilibrium.
stay in equilibrium. Done?
Yes.
Okay. Any other issue?
No, ma'am.
Great. Now what does the second law says? Second law says me that here the force is 0, but here what happens when the force is not equal to 0? So when the force is not equal to 0, force is equal to MA.
Yes.
Okay. That means the total forces which are acting on any object will be equal to MA. What are the total forces? Like in this case, we have sliding force and frictional force. Let's say my frictional force is more. So I will write my frictional force subtracting my sliding force is equal to MA.
Yes, ma'am.
This is my x-axis. Let's come to the y-axis. So mg will going to have two factors, one over here, right?
Yes, ma'am.
Okay. So normal force minus this factor, let's say it is mg cos theta. So I will write n minus mg cos theta is equal to ma. And in this equation with SF, I will add mg sin theta. Understood? And I will equalize it with MA. So this is my y equation. This is my x equation. And I will solve it as per equation in two variables.
Yes, ma'am.
Understood? Understood the theme?
Yes, ma'am.
This is how you have to solve in exam also. Okay. Now let me give you very fast 1 or 2 examples so that you can understand this thing. Okay.
Okay.
I'll give you one question and then I am expecting that you will solve one question for me. Okay. If it
Yes.
is possible for you, please solve that for me. Okay. Okay.
Yes.
So the question is, let's say here I have a fixed terminal and here I am hanging a mass of 2 kg. And again here I am hanging a mass of, let's say, 5 kg. So let's draw the FBD for 2 kg now. So this is 2 kg. Let's say it is having a tension T. Clear?
Yes.
Okay. Let's say for 5 kg. So it is having a tension T1. String change, the tension force also change. And here I will be having 5g. Let's say my g is 10 meter per second square. Okay. I'm taking the standard cases right now. If it is asked in exam to take 9.81, you will take 9.81. Done?
Yes, ma'am.
Great. So let's draw the FBD for 2 kg right now. So in the upward direction, I have tension T. In the downward direction, I have 2g. Any doubts?
No, ma'am.
Great. Now with respect to 2 kg, I have tension over here also, and that is in this direction. This will also be T1. So here also I will have one more force, that is T1. Correct?
Yes, ma'am.
2 kg is also holding 5g, right?
Yes, ma'am.
Okay. So my equation become here T equals to T1 plus 2g. Any doubts?
No, ma'am.
Great. Now next, let's come to the second point, 5g. So for 5 kg, if I am drawing my FBD here, I will have my 5 kg, and in the upward direction, I will have my T1. Correct?
Yes, ma'am.
Okay. So that means here I got my formula T1 equals to 5g. Okay.
Yes, ma'am.
Okay. So here I can write it as T1 equals to 50 Newton. Let's apply this in my second equation. You just have to get two equations. This is one equation. This is second equation. You will solve it as equations in two variable as per maths formula. Okay.
Yes, ma'am.
Akshita, see here right now we are going one by one. Okay, one-on-one class is going on. Whereas this class was fixed at a very fast-paced study, a very crash course study, so that you can crack the exam. Done.
Yes, ma'am.
If you want me that, ma'am, I want to go in depth, I want to solve more questions, then I will go slow as per your demand, and we can align more classes other than 1 month. Done. But you have to convey that to me. Otherwise, I will go as per the given demand. Okay,
Okay.
Akshita?
Yes,
Because
ma'am.
you have to fix it that whether you are able to solve these questions or not in exam. This is basically for your exam only. Done, Akshita?
Yes.
So you have to be very much clear with your mind that, ma'am, I need some extra knowledge. I need to practice more with these questions. Otherwise, I will cover one chapter in one lesson. Okay.
Yes, ma'am.
So you have to fix that. In your mind, you just fix it that, ma'am, with this chapter, can you go for more classes? I will give you more classes till any other student is joining, because already one batch is running. Done. So if you are joining, it will be good that I will give you extra knowledge. You are single here, so you can take the credit of that. That, yeah, ma'am, I want to go in depth. I want to solve more questions. Then if you give the same payment and whatever the fixed thing is there, next month also we can run and we can go in the more depth question answers. Done. So you just have to tell me about that. Please don't go like that. Okay. Otherwise,
Yes.
ultimate criteria is to let you understand these criterias. Done.
Yes, ma'am.
Coming back to the topic. So T equals to 50 plus 2G is 20. So I got my tension as 70 Newton. So tension T is 70 Newton. T1 is 50 Newton. Any doubts?
I just got a little bit confused over is it T1? And then, like I didn't like understand what you wrote, after T is equal to this part.
Shall I
Like
write it again?
Yes, ma'am. You substituted 2 into something, but, I understood till the right side.
This one or this one? This one you understood.
Can you show me the cursor? I will.
Yeah, here is the cursor. Yeah. Yes, Akshita, this one.
I'm not able to see the cursor, ma'am. But the left and the right, I was the center
Okay.
substitution part alone. I couldn't.
Okay.
like-
Which one you want me to repeat?
The t is equal to t1 something 2g minus 2.
This one. Can you see the? You cannot see the cursor.
No, ma'am.
Okay. 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 I'm putting a. This you are not able to understand.
Yes, ma'am. The words.
Okay. And this you have understood.
Yes, ma'am.
Great. Now let's come to the topic again. Okay. Now check here again. What I was telling is I was drawing the FBD diagram of
Yes.
this. That is 2 kg.
Yes.
So for 2 kg in the upward it is tension T. In the downward it is T1. So downward I had drawn T1 plus as it is a 2 kg. So with a 2g of the weight it will be hanging.
Yes, ma'am.
Correct. So in the downward I will be having two forces T1 and 2g. Any doubts?
No, ma'am.
Sure.
Yes, ma'am.
Okay. So that means at equilibrium my tension force is equal to T1 plus 2g.
Yes, ma'am.
The forces of equal direction are added. The forces of opposite direction are subtracted. Okay.
Yes, ma'am.
So T is in equilibrium with these two forces, that is T1 plus 2g. So I had written here T1 plus 2g. Where
Okay.
did I had written? I had written here.
Yes.
Okay. So that means
The plus sign, I thought it was something like another t.
no, I will rub it. Check. I will write it again. So it is T1 plus 2g. So this is second equation.
Yes, ma'am. Yes, ma'am. I got it.
Got it now? Okay. So this is
Yes,
my,
ma'am.
what is happening here? Okay. So this is my second equation right now. Done? So basically, what is T1? I got it here 50 Newton. So I had written 50. Done?
Yes.
Then what is 2G? 2 into 10. This is the value of 10. So 2G is 20. So I got the value of tension T also. So here it is hanging and it is keeping a load of 70 Newton, whereas T1 is keeping a load of 50 Newton. Understood? It's written here.
Yes, ma'am.
Any doubts now?
No, ma'am.
Great. Now let's move ahead with the next question. If you are able to solve, I am giving you 2 minutes of the time. Please do it very fast. If you are not, then I will help you. Done? Suppose here I have a mass, let's say of 5 kg again, and it has been winded with another string. Okay. And here it is having an angle of 30 degree. Please solve. Can you find the tension in the two strings?
Yes.
Yeah, Akshita, please do it. You can use your thing and you can write it on the board itself. No issue.
Okay.
Yeah. But little bit you have to be quick, okay? Kindly be quick.
First, we have to draw the free body diagram for this, right? This part is here, so the tension will be here. So, this is the point mass. This one is also a spring, ma'am. So this.
First, you find out the tension in one string, then you find out the tension in the second string. That will be more easy.
Yes, ma'am.
Are you able to? If you are not, I'll help you. Don't worry. But kindly be quick.
Yes, ma'am. We should use T cos theta
Hmm.
and then
You have to find the tension in the strings as per 5 kg weight.
yes,
So for 5 kg weight, you have to draw x-axis, you have to draw y-axis. Let's be clear with that. First you find out x-axis and y-axis, then equalize the two opposite forces as per Newton's first law,
yes.
and hence find out the tension. Okay?
Can you repeat the last line which you said, ma'am? Your
Yeah,
voice.
I'm saying, am I audible now?
Yes, ma'am.
Yeah, I'm saying that first you find out x-axis, y-axis. Sorry, x-axis, y-axis forces. First
Yes.
step. Second step, equalize the two sides of x for one equation. Equalize the two sides of y for y equation.
Yes.
You will get two equations.
Yes.
Then solve equations in two variable, where one variable is tension T1, second variable is tension T2.
Okay.
Hmm. Akshita, are you able to, or shall I try?
Is it T1 cos 30 minus T2 is equal to 0?
What did you say? Cos 30?
T cos 30 minus T2.
No.
But I'm kind of stuck now.
Yeah, it's okay. It's okay. No issue. That's why I'm saying just tell me. I will do it for you. This is 5 kg. Here I
Yes.
have the tension. Let's say I'm having here the tension T1. Here
Yes.
I'm having the tension T2. Suppose.
I
Okay.
took this part as T1 and the second part as T2.
No issue. Let's do it like that. Let's say this is T1. Let's say this is T2. Now it's okay.
Yes.
Now I will draw. For this tension force, I will be having two components. One here and one here. Right? One
Yes.
up, one down. Two components are always drawn for the slant forces, oblique angle forces. I explained you this yesterday.
Yes, ma'am.
Okay. So, here is the angle, right? But your angle should be here at the vertex of the tension force with the mass. So I'm not having angle here. Let's bring the angle over here. How? This line, I guess, is parallel to this, and this is nothing but a transversal. Check.
Yes, ma'am.
Correct. So I can bring alternate interior angles theme over here, and this will be 30 degree. Correct.
Yes, ma'am.
Okay, so I got my theta angle with and the on the vertex of the mass with the slant force. Correct.
Yes.
So angle carrying line is always cos. That I had told you yesterday also, right? So this will be T1 cos 30.
Yes, ma'am.
This will be T1 sin 30. Now
Yes,
here I have mg. Any doubts?
No, ma'am.
Okay, you want to ask anything, you can ask me anytime. Okay, you can stop me in between. So after this, I will be having two equations. T1 cos 30 is equal to mg, that is 5g. Correct?
Yes, ma'am.
Okay, so we can solve this. The T1, what is the value of cos 30? Put it over here. This will be 50. Solve this and you will get the value of T1 over here. Correct?
Yes, ma'am.
Great.
It's the,
Now,
30 degrees in radian. It's in radian, right?
cos 30 degree. No,
It should be in
you just have
radian
to find
or
out cos
degrees,
30.
ma'am.
No, it should be theta. It's not in radian, it's a degree. Yeah, normal theta.
Oh, yes.
Yeah, just find out cos 30 degree. You are asking about your calculator.
Yes, ma'am.
Okay. Do it normal. Okay.
Yes.
Yeah.
I think it
Now
is-
let's equalize the y directions. So that is, I have got T2 equals to T1 sine 30. From here, I will get the value of T1. I will put it over here, multiply with sine 30. I will get the value of T2 also. Check. Any doubts?
Okay, ma'am. We are this T130 and T2.
You got the answers, no? You got the answers or not? Solve it in your calculator. You will get the answer. What is the value of cos 30? Tell me.
Cos 30 alone was
How much?
3 by 2. 0.866.
0.866. So 50 divided by 0.866 is how much?
57.735.
We will write only 57.7 because 3 digits are required in exam, not more than that. You have to apply
Yes.
significant figure rule in the exam. The number of
Okay.
maximum significant figure is given in the raw data of question. That much only you will use in your answers. Understood?
Yes, ma'am.
Okay. You cannot change the number of digit rule. Okay. Now let's apply it over here. So my T2 will be equal to 57.
57.7 sin 30.
Sin 30 is how much?
Sin 30 alone is 1 by 2.
1 by 2.
0.5.
So 1 by 2 of this is how much?
28.85.
28.8. So 28.8 Newton here, 57.7 Newton here. So I got that both the tensions. Understood? Any doubts?
Yes, ma'am. Since you said
Understood.
on the significant figure, the answer would be like 28.9, right, ma'am?
What was your answer? 28.8? 7?
85. 85.
85. And after 5?
There was no other. It
Digit.
was only 28.85.
28.85. Okay, so you can put it as 28.9. Okay?
Yes. Yes.
Okay, done. So after this, let's have a question of sledge also. Suppose this is my sledge and here I am keeping a mass, let's say 5 kg. I am tying here a pulley. Over this, the thread is going and it is coming here with a hanging mass of 2 kg. Yeah, question is find the tension in the string and the normal force. How will you do it? I will show you. Check. You can do it, Akshata. It's very good.
No, no.
Please.
I'm just like trying to figure out the diagram.
Yeah, sure. Please do it if it's possible with you. And here I have an angle. Let's say
The strings are
theta
same, right, ma'am? The strings.
is same.
So this T1 will be equal to T2.
Okay. They are not T1, T2. You can put them directly TT.
Okay.
Just put one variable, that is TT. Yeah. What are the other forces which are acting?
mg.
Yeah. So here I guess it will be 2G. Let me write it for you. Don't worry. 2G. Here it will be 5G. What
Yes,
else?
ma'am. And then there will be normal force. Like
Normal force also. Where in this direction it will
Yes,
be a
ma'am.
normal force. Okay.
Yes,
So
ma'am.
basically you have to tilt your x and y direction in the case of sledge. In the case of sledge, your x is not like this, but your x is like this.
Yes,
Similarly,
ma'am.
your y is also like this. So you will have this type of diagram on sledge.
Yes, ma'am.
You have to change the orientation of x and y. Done. So I will find out here. Let's see. I'll show you. Please have a look very carefully. You have to do it in exam also. If this is theta, this is 90. This is, I guess, 90 minus theta.
Yes, ma'am.
Here I will have two components, one here, one here. Correct?
Yes, ma'am.
Great. So here it is theta, here it is theta. So I will have here 90 minus theta. Keeping this as 90 degree, this angle is also theta.
Yes,
So I
ma'am.
got my theta angle on the verge of the mass with the tension. So I will write here 5g cos theta. 5g sine theta. Correct?
Yes, ma'am.
Okay. Great. Go ahead.
So n is equal to 5g cos theta and t is equal to 5g sine. It's in the opposite direction, so it is minus, ma'am.
Yeah.
Pi g sine theta minus t is equal to n minus 5g cos theta, something like that.
No, you are correct what you are doing. You have to find it now. T equals to 2g. What you are doing is correct. Just find out tension T and then put it in equation for normal. Then find out normal force. Give me the two answers. It's very easy.
Yes, ma'am.
Why you are stuck? Right?
Yes, ma'am.
Solve it. X and Y direction. Did you got the answer?
No, ma'am, no, ma'am. Just give me a
Yeah.
second.
Yeah. Have you ever practiced these questions before?
No, ma'am. This always I get stuck while doing solving the diagram questions.
Okay. Now the theme is clear to you or not?
Yes, ma'am. I'm just trying to solve the mathematical part.
Did you got my thing or shall I solve it for you?
No, ma'am, I can solve it. I will tell you the answer. If it's wrong, then you
Yeah, done. Give me your answer.
can.
So you have changed your schedule with the maths class for physics, right?
Yes, ma'am.
So every day you are having maths class, Akshita?
I have maths classes 3 to 4 days, ma'am.
3 to 4 days.
Yes.
Because 5 to 6 you are aligning.
No, I am not sure if this is right, but is 50 minus t is equal to n?
What is the final answer that you got? Just tell me that. What is the value of n and what is the value of t? Just give me the two values. That's it.
I only got till 50 minus t is equal to n, ma'am. I solved the equations, but still I feel like I'm somewhere stuck.
Let me solve it for you then. Don't get confused, Akshita. Please listen. I will solve this one first. Why? Because this will directly give me the answer. T equals to 2g. 20 Newton. Easy?
Yes, ma'am.
Okay. Now let's solve this one. So here I have n equals to 5g
It will be
cos theta.
50 minus 20. I think n is 30.
Yeah. Okay.
I
So
forgot
50.
this part.
Yeah. So basically, is it 30? No, it should be 40. No, 50 multiply cos theta.
I will check now. 50?
Huh. Multiply cos theta.
Ma'am, isn't
Cos.
it 5?
Okay. Have you sorted what is theta?
Yes, ma'am.
Yeah. What is the value of theta that you got?
I kind of solve it with the whole part, ma'am.
I guess I can solve it like this. T equals to 5g sine theta. Clear?
Okay. It was like 50. 5 into 10 into sine 90, I got it as 50.
Where is 90? It's not 90. Listen, relax. Listen. We got the value of t over here, right?
Yes, ma'am.
Apply this over here, 20. 50 sine theta. So sine theta is equal to 20 over 50. Done.
Okay.
0, 0 cancel 2 over 5. So that means theta is equal to sine inverse of 2 over 5.
Yes, ma'am.
Do you know when the sine and the cos angle goes on the other side of equal to,
It will be
they become
inverse.
inverse. Yeah.
I
Tell.
thought this was you took 90 minus theta, and this became theta, this became theta. I kind of assumed it was, since it kind of looked perpendicular, I thought it was like 90. So I took the theta as 90.
Akshita, listen very carefully. Always when my angle is at slant angle, like this, where we have here also, you have to define it in two ways, one down, one up. In such a way, one will become x-axis, one will become y-axis, and this will cancel this now.
Yes, ma'am.
Okay. Next
Yes,
thing, if I'm connecting this and this is theta, so this will be 90, correct? Hence,
yes,
this
miss.
will be
90
90 minus theta. This will be theta. Why I am finding out theta, Akshita? Because at the vertex, I should be having theta line, any one out of the two, either x or y, with my tension force,
Yes,
with
ma'am.
my central line force. Understood what I am trying to convey?
Yes, ma'am.
With my slant line force, I should be having a theta line.
Yes, ma'am.
So I will not play with 90 minus theta. I will play with my theta. I have to find out my theta at the vertex.
Yes, ma'am.
Okay. So try
Yes.
to find out theta at the vertex. Don't play with 90 minus theta. Why I am taking out 90 minus theta? Because this is maths rule. If this is 90 and this is 90 minus theta, then
Yes,
definitely this will be theta. Correct?
Yes, ma'am. Yes, ma'am.
Now understood what I am trying to do.
Yes, ma'am.
So if I get theta line, then this is my cos theta factor and this is my sin theta factor. This is
Yes.
how I come to know. Understood?
Yes, ma'am.
So Akshita, the time is up, but I would suggest you to take more classes because I don't know seriously about your performance. It's just 2 classes we have been done. But if you need more classes, kindly convey this to Miss Sonia. She will convey that to me, and we can do more numericals because here you are. Your ultimate goal is to reach for the finals, and my ultimate goal is to teach you in such a way that you reach your finals, right?
Yes,
So
ma'am.
if I'm going at a very fast pace, like I had solved everything yesterday, I will never come to know, Akshita, that you are having such issues. Understood? It's just
Yes,
that today I had just taken a small test that Akshita, please solve this so that I can also be aware that you are
No,
getting
ma'am. I always get confused with the whole this part.
diagram.
Yeah.
Hmm.
I
I will give you very small steps. It's very easy. It's very easy.
Yes.
Seriously. But just you need to command over the basics of the concept. Okay.
Yes.
So just do let me know that if you need more classes, I will align it according